right. Good afternoon, everybody. Hope you're all having a great weekend so far. So, apologies I couldn't make it to do a stream yesterday. I had to go visit my parents to help them out with some stuff. But we're here today. So, if it seems like I'm a little lower energy, it's because I am. I was higher energy this morning, and then I worked out, did a hard workout. So actually, I do those Apple Fitness Plus workouts sometimes, and I did one of those HIIT workouts, and that just kind of drained me. But I committed to this. I hate canceling the streams. I've only canceled one stream so far. Yeah, we'll see how far we make it today. So, speaking of the stream, we are continuing along with our movie ratings model project. So, just to give a quick recap on what this is, so I like to follow this podcast called The Water Cooler, and there is one of the hosts on there named Kalen Bean who gives ratings to different movies, and I thought it would be funny to create a predictive model around his movie ratings. And so you might recall we've already done 2 streams so far. So the very first stream was just collecting the data that we'll need for our project. And then the second stream was doing a screen scrape to try to get the Rotten Tomatoes audience score. I think if you watched another stream, I mentioned that I actually kind of scrapped that idea for 2 reasons. Number one was when I originally wrote the blog post for the first one where we actually did the data gathering and I posted it out to Tor Data Science, they very, very, very nicely said, screen scraping is a very, tricky subject, from a legal perspective, and they asked me to not post anything about screen scraping, especially with Rotten Tomatoes. And just to respect them, I didn't want... I'm going to honor that. But I did find a Python library that will help me get the Rotten Tomatoes audience score that I want. Unfortunately, I have not had the opportunity to implement it yet, which is fine. I actually think, so now with this stream, the idea is that we'll go ahead and start doing our feature engineering. And I actually think this probably will be a 2-parter. I don't think we'll get through the full feature engineering in a day. So actually, in regards to that, I'm coming into this with pretty fresh eyes. Now, I know that whenever we did our data gathering, that I, of course, saw some things that... or some of the features that looked interesting, but honestly, I have not delved into this at all. So I don't know what the data types look like, really. I don't know what nulls are like, and I don't know what anything else is like. So what we're going to do is we're going to do this all together. So just to show you, so again, I'm not a data scientist. I'm actually a machine learning engineer. But I would imagine if you were a data scientist doing real work, this is what it would be like coming into it with, fresh and clean eyes. And so what we're going to be talking about as we go through each of these features is how are we going to take this raw data set, how is it important to us, and then how are we going to use code to properly transform it whenever we put it into our model. So yeah, with that, let's go ahead and get into things. Let me go ahead and share my screen here. Excuse me. Oh, by the way, I think I put in the LinkedIn post that to bring a drink and that I was going to bring my own Polar Pop. So I ended up having McDonald's for lunch, and so I don't have a Polar Pop, sorry, but I do have a McDonald's Diet Coke right here, so they got some good Diet Coke, although I know I don't know if this is more or less environmentally friendly, but I miss the foam cups, because these just sweat really, really bad. I don't know if you can tell on the stream here. Look at that. I have to use a coaster. Oh, by the way, my coasters are really cool. So this is my, if you know what this is, so I actually got the rest of them back here. These are actually Portal coasters. So my wife found them on ThinkGeek a couple years ago. They might still be available, but yeah, so those are my coasters. Sometime I'll have to go through all my nerd stuff over here, what all this is. So in case you're curious what this is not gosh, what are those figurines called? I think they're not. Is Gundam it? Maybe. I apologize. I'm not a Gundam fan per se. Not that I dislike Gundam. I just have never got into it. But that's actually the original Power Rangers Megazord. So from the original series. And actually, all those pieces come apart to actually form the separate pieces that were the different Power Ranger stuff. So so I know the Blue Rangers, Triceratops vehicle and stuff. So. Anyway, you didn't come here for that. Back to the stream. All right, so bottom right here. All right, so let's go ahead and open up Safari. We're going to continue for our feature engineering because, it makes most sense to do this out of a Jupyter Notebook. We are going to be creating a new Jupyter Notebook today. So if this is your first time, by the way, joining this particular stream, I do want to show that, or remind you all that this project is available on GitHub, and I'm doing my best to try to keep it updated. I was starting to update the README. I apologize that I have not finished that yet. So this is the README here. And so you can see I need to finish the data dictionary yet, but I'm going to do stuff like that. But the reason I bring this up is so you can see that there is a data folder in here. So if you want to follow along, even if you haven't been like curating the data yourself, I saved it all out as this alldata.csv, and therefore you can pick up immediately from here if you'd like. So just note, so github.com/dkonlay/movie ratings model is what that URL is. So back to here. So I'm coming into my movie ratings model, my notebooks, and I'm going to create, oh, it looks like I already did create a notebook. Is it empty though? Oh, that's interesting. I don't remember. Well, actually, I'm going to just delete this because it's probably, yeah, it says 3 months ago. Okay, so I'm going to delete this because I think I was starting to do it by myself, but that was before we were doing the whole stream thing. So let's just do this together. So I'm going to do a new Jupyter Notebook here, and I'm going to call this feature engineering, which is just the name of the one that we just deleted. So okay, so I'm going to, in Markdown here, I'm going to put feature engineering, and I'll clean this up later. I usually like to add like a little description on each of these notebooks. Oh, by the way, as a reminder, if you are watching live on YouTube right now, you are welcome to ask any questions using the chat functionality. I am monitoring it down on my other monitor below, and I will be very happy to answer any questions as they arise. Okay, so for feature engineering, we need to import our Python library, so importing, let me make this a little bit bigger for you all, so just in case, because I know I got my big old monitor here, but if you're watching off something like a smartphone, that might be a bit small for you all. So importing the necessary Python libraries. So I'm actually, one quick thing as I'm typing here, you might note that I'm kind of jumping ahead a little bit. So we have jumped into doing data gathering, and now I'm saying I'm going to do feature engineering. Data scientists actually might do exploratory data analysis before, but I kind of like to do the feature engineering in tandem, especially because even though I don't know what the data types and nulls are for these features, I know like they aren't that complex, and I don't plan on doing anything like extremely fancy with our feature engineering here. So, but yeah, just keep that in mind. So when it comes to like the whole model development life cycle, you get your data gathering, then you usually have like exploratory data analysis as its own step, and then you do feature engineering, then modeling, then deployment. I'm kind of not skipping, but doing the EDA in tandem with the feature engineering here. So, okay, so we imported pandas. Now we need to import our data set. So I'm going to call this df, df being short for data frame, equals pd.read CSV. All right, so I think it's up one, data raw all data.csv. I don't remember off the top of my head. It's been a little bit since I've looked at this. All right, so I always like to do just like a quick df.head. Okay, so everything in here is good to go. So you can see that these are all of our things. I just want to make sure that, oh, it looks like oh my gosh, I started to populate this apparently, but oh no, I am so scared. Did I do something silly? Oh, so I mentioned before that I was trying to use this one like new library that like, yeah, and I think I may have accidentally, all right, so let me check the length of the df. I think I may have accidentally overwritten this. df dot, okay, so there is, okay, maybe it all is in here, but all right, so first things first, just because I mentioned, so there was started to be a new feature in here, but I don't think I got it populated. So df, what was it called? RT audience score dot value counts. So value counts, and I don't remember if I showed this before, but value counts, what it does is it looks like everything in here within this particular feature, and then like gives like how many values there are for anything. So you can see that there's only one of for like the first 7 movies. I didn't finish this because I was running into some bugs, and I didn't want to take this stream to do that, and because I knew this would be a 2-parter anyway. So you can see only 6 got populated out of the 122, which means everything else is null. So just for our purposes today, I am going to drop this column, but I do plan on using it. Temporarily dropping. I do plan on using it later, so temporarily dropping the RT audience score column. So the way we do that, if you don't recall, so df.columns, df.drop columns equals RT audience score. Is it brackets or is it curly braces? I can't remember. Well, we'll find out here in a second. In place equals true. All right, so apparently it looks like that works. So let's just do a df.info real quick. Okay, so you can see everything in here. Looks like we have 122 movies, although I should probably remove one of these. So one of these movies is, you can see, so if you recall, I'm actually keeping all of this information in a Google spreadsheet. And so you might be wondering, well, why did you not populate the rating for one of these movies? And that's because Mr. Bean here did not give me the rating for a movie called Air Force One. And so if any of you water cooler fans are watching, you'll know it's a little bit of a running joke because he accidentally forgot to give the score, and I've been asking for it for weeks, and like, yeah, he kind of just keeps ignoring it. But that'll be interesting though, is like maybe at some point when we actually get the model, then like the real thing when it's done, then I can use like Air Force One as my first real test example. So speaking of that, I do want to get rid of this row right now. So df, I don't remember how. So I'm not super great with the loc functionality. I think it's df loc is it index? Let me go and reference one of my other things here. So I was looking at the data gathering, and so the one thing I've noted before is it's more important to understand the concept of what you want to do rather than the syntax, because the syntax, you can always go back and do a Google search or look at some of your old code. As long as you know what you need to do, then the syntax is just a Google away. So I was looking for loc. I wonder if this will work. All right, so loc, we pass in the index, and then we look at for that. Okay, so I don't want to do that. I just want to find. Okay, so I wonder if I can do df movie. Oh wait, df. Well, let me just Google. So pandas, how to remove row. So again, I don't remember how to do this, and that's fine. So it looks like it is pandas.drop, labels equals none. So the pandas documentation, I'm honestly not super like a big fan of. I like to see the parameters and what it returns, but the examples are not very good in my opinion. But somebody else may have a different opinion than I do, and that's totally fine. Okay, so, well, actually, let's just find what the index value is for this particular thing. I know how to at least do that. So df movie name equals Air Force One. Okay, so you can see that it is location number 121, and so I'm curious then, like, how do we do a drop? Sometimes it's just easier to go and look at like somebody else's blog to see what they wrote. So this person, Shane Lynn here, he might have something good for us. Shane, what do you have for us? So it looks like we do a drop. Index value if deleting rows, column names if deleting columns. Okay. Index values if deleting rows, column names if deleting columns. Okay, but so I just want, all right, so the labels, so axis equals 0. Okay, and then in place equals 1. Well, let's just do it without in place just to see if it'll work, which it should. So let's come back to this. I can close this out now. Okay, so df.drop, what was it? Labels equals 121, and axis equals 0, because 0, the axis representing the columns versus the rows. I think, so columns is 1, rows is 0, and well, let's see if that works. We should be able to find that out here in a second. So, oh, that must have been the last one on the list anyway, because it looks like, okay, so Talladega Nights, that looks right. I don't see, because they just had another movie night last night. Did I not? Oh, that's right. I didn't get that added in here yet, but that's okay, because we don't need the new rows yet, because we could still continue with our feature engineering. Okay, so df.drop labels 121, x equals 0. Except I don't like that we're necessarily doing this. So I wonder if there's a way to extract whatever the label the index value is here. So get index value from row. So I'm going to do a Google get index. No, not Google. The pandas. If I could type. Sorry, I don't know if y'all can hear that, but that's really creepy. Like, it sounds like a jet just flew right over my house. It's not very common. Okay, so pandas get index value from well, get index value of row. Yeah, of row should be fine. Okay, so get in values, blah, blah, blah. Oh, this is 2016, but maybe 2016 should be okay. All right, so df.index. Okay, maybe. I always learn new things. I've never tried this before. df.index. Do I just wrap it in here? How does that work? Arrange it to, okay, so maybe this is a little old. All right, so, oh, no, I did something wrong here. Okay, so df.index, you just put it in brackets. All right, so df.index. Okay, so let's try this again, folks. Oh my gosh. Let's try this again, except let me highlight our cell here. All right, so df.index. All right, is it going to give me the proper? Okay, so this is going to work. All right, so instead of just passing in this thing here is, I'm just going to call this AF1 index. Well, I wonder if it says, what was that, to list? Is that right? Dot to list. Let's try that. Dot to list. Dot to list. All right. Okay, so that gives me exactly what I need. All right, so I'm going to call this AF1 index equals, and then labels. I think that we should just be able to pass, because it already does include the brackets. I think we should just be able to pass it in like this. But the reason I wanted to do this is because, you know, when I start adding more movies to this, then naturally Air Force One's index is going to change. And therefore I need to make sure that it is programmatically doing that instead of trying to statically assign that one value. So, you know, just being mindful of those things. Okay, so it looks like that worked, which means then I can do an in place equals true. In place equals true, and we should be good to go. So let me check. df, let's do the same thing here. df movie name name equals Air Force One, and we should come up with nothing here. Force One, which, by the way, that was the very first time I'd ever seen Air Force One. Like, that was a gnarly movie. Gnarly, well, not really gnarly. It was just not what I was expecting. I don't know. I guess I don't know what I was expecting, but I was not expecting what I watched. Okay, so, all right, we have removed that row. All right, so let's just take a look. What features do we have remaining? All right, so some of these features are unique identifiers that we are going to, we're not going to feature engineer, but we won't use them in the model. I don't necessarily want to get rid of them yet, because I want to keep them around because I don't know if we'll need them. But let's just take a look. So just some descriptors of things. So movie name obviously is just the movie name. This will not be used in the model, like the actual training the model, just because, you know, these models are predicated on like numbers, of course, and so movie names you can't really translate into numbers, and you know, I don't even know what you'd want to use those movie names for as a feature, so we're going to drop that. So here's the one interesting thing is we actually, if you recall, we actually have two different models that we'll be creating because Mr. Bean here, Kalen Bean, gives two different ratings. He gives a 0 to 10 score, float score, and then he gives a binary yes or no. So actually, even though we'll be creating two different models, I want to use based off of the model, one feature to feed in for the other if it's not being used as a predictor value. So in other words, for example, like whenever I go and train my binary classifier here, I want to use this other one as a feature into that because it'll be interesting to see, is there a correlation between how Kalen gives a yes or no based off of his scale rating. And the interesting thing is because with Kalen in particular, is you'd think that like basically everything like above like a 6.0 would automatically be a yes, but his ratings are kind of crazy. So like so sometimes like he might give a no rating, but still give it like a 7.0 just because he's got mad respect for the movie or something like that. I don't know, that maybe not exactly like that. So all right, we will be keeping those obviously as the predictor variables for one, and then the other thing for the other. And fortunately, I don't think we have to do any feature engineering on these. Well, I take that back. We actually do, or let me, because I think because I'm seeing that this is an object type, I think I do just have it as a yes or no, so I think we just need to change these to like a 0 or 1. No big deal. We can do that pretty easily, but these are all float values already, and there are no nulls here. So we're actually already good to go here. Okay, so that's what we're going to do for this one, and we're just going to talk through these right now, and then we'll actually start writing the code on actually doing what we need to do. So next couple things here are TMDB ID and IMDb ID. Actually, we really don't need to keep these. So whenever we actually save out the clean data set, I think I am going to keep movie name just to keep things like as a reference. But we actually don't need these IDs, so we actually will just go ahead and drop those IDs, just because we were just using them to help us with our data gathering. Excuse me. All right, next up is budget. We'll come back and look at this one to see if we need to do any engineering, but it looks like this one should already be good to go as it is in integer form. We may have to do some scaling based off of the algorithm we choose, but that will actually come later. So that's actually one interesting thing to bring up is, so dependent on the different algorithms that you use, you may or may not need to do scaling on your data. So you could use either sort of like some sort of like standard scaling or normalization. And I've always wondered if, and sound off down on the chat if you're watching and give your opinion, do you qualify that as feature engineering? Because I don't know. And the reason I don't know if you won't qualify that as feature engineering per se is because you're not going to do that for every single algorithm. And so you might recall with our Titanic project, we settled on the random forest classifier just to keep things easy. We didn't try any other algorithm. With this particular project, I do want to try multiple algorithms. I'm going to try 3 or 4 of them, and some of them aren't going to need that scaling. And so whenever it comes to like this feature engineering notebook that we're going to be completing, I am not going to do the scaling as part of this, but I will do the scaling for those algorithms. And we'll talk more about what scaling means and why it's important in a future stream. Okay, so next up, primary genre and secondary genre. So these are, we're going to have to do a couple things here. So you can see we actually do have some null values in here, both here and here. And we'll look at this in a little bit, but these are obviously string-based values. So we are going to what we're probably going to do with these is just basic one-hot encoding. And then the one-hot encoding will also be able to handle the nulls appropriately, basically assigning an other genre, if you will, to these things. TMDB popularity, I really don't remember what this is, but it's in float and it's in, it looks like there's no null, so maybe we don't have to do anything. Revenue, revenue and runtime, both here, already in integer format, so we may already be good to go there as well. So I'm actually wondering, we might actually clean through pretty much all of these today, because this data is actually pretty good already. And so keep in mind, most data is actually not like this. I'm actually kind of surprised to see this, that the data is so good already, in that, usually there's a lot more nulls or a lot of weird characters or things like that. But in this case, all of this stuff is almost good to go as is. And if that's the case, then, we'll just take it. Why not? But I do want to actually look at the values of some of these things because I don't remember what these are supposed to mean. So we will look at them. We'll do our diligence, of course, still. All right, so TMDB, vote count, and average both appear to be good, both in float versus in format. IMDb ratings and IMDb votes. Also, same idea here with so those should be good to go. Year now, so I do want to do something with year. So a here is representing the year the movie came out. So for example, what was it? I think 2019 is when Avengers Endgame came out. Which funny analogy that one time somebody brought up to me, and I don't remember who it was. Avengers Endgame, the last big movie before COVID hit. It's just super ironic that's got the name Endgame, and you could argue that because of COVID, that it was the downfall of movie theaters as we know them. And I'm not saying that movie theaters are going to go away, but with the whole now you can kind of stream things. It's interesting that Endgame, it was the last big movie. It's just very ironic. Anyway, so you can't use year by itself, even though it is in format, just because So you got movies that are created in 2019 and then 2018 or 1994 or whatever. So this is not a good judgment. You can't just use the year right out, because those values don't really have any inherent meaning, and they can create, if you just use them as is, they can create a weird unnecessary bias. So I actually am going to this is probably the one that we're going to feature engineer the most, which is not really that much. And what we're going to be doing is creating a relative value of how long the movie's been out. So basically saying, all right, how old is the movie, basically, from 2021, of course. Rotten Tomato critic score. Now this is interesting because we see some null values here. And I know this is a string. I know what the issue is here is because it's got the percent sign, so we can remove that really easily. I don't know how we're gonna handle the null values here, because I don't want to necessarily, because it's not really fair to do. Well, we might just end up doing an imputation of value. Well, or I don't know. If there's anybody watching, so just being transparent, I don't look at how many people watch these Streamlabs live because I'm a little self-conscious of that. So maybe nobody's watching right now, and that's okay. But if you have any opinions on what to do with the critic score here, do we just assign the nulls of 50% and just call it a day, or do we try? I don't, because I don't think it's fair to do imputation. So just a reminder, what imputation is that it's inferring what we should do here versus compared to everything else. That's not really fair, I think, in this case. So yeah, and then same here with the Metascore. So Metascore, in case you're not familiar, there's the website Metacritic that also gives an aggregation of scores based off of the 0 to 100, and you can see we got some more nulls in here. So I don't know how to handle those, so we'll come back to them. All right, so let's just work our way from the top down. So movie name, we'll go ahead and ignore because we don't need to do anything. I do want to look at the bean scale rating to assure that I don't have any weird value. Well, no, I think it should be fine because I have looked at. So keep in mind, these two features here, I populated myself, so I know they're right. So the bean scale rating, I'm not going to mess with. Now, of course, we do need to change this here. So df bean yes or no. Being yes or no. So you can see there that we got a bunch of yeses, a bunch of no's, value counts. I love value counts because I just took it's really telling to see what sort of things he said. And so this is the other interesting thing about models. And I wonder, because I never actually tried to do this to see if anybody's ever created another predictive algorithm for somebody I don't know, Roger Ebert. Well, because the thing with ratings, and I've even noticed this on some of my favorite gaming websites like IGN, this is not a knock against anybody, is that we have the tendency to review only the things that we like already. So it's kind of a little bit biased in that perspective. And I think that this is the case as well, is, Kalen's not trying to go out and watch just whatever movie he wants. He wants to watch the movies that he wants to watch. And so you can see that we have a little bit of a class imbalance here, where we have more. He's obviously liked a lot more movies than he's not seen, which of course you would hope is the case. I personally hope that every movie that I'm watching that I choose to watch is good. Of course, I recognize that there are some that are not going to be good. I'm looking at you, newest Star Wars trilogy, but yeah. But most of the movie, so this is not a surprise to see, but you can see we do have to do a little bit of engineering to get this from to be from yes or no or 201. So in order to do that, let's do some engineering. So I'm trying to think. Because I know there are a couple ways you can do this, and I kind of just want to keep this simpler. So I think I'm just going to do a for loop. So for index row and df dot iter rows. If row dot well, sometimes, all right, so I'm not actually going to overwrite anything yet. Sometimes I just like to print things out just to make sure that everything is working right. So for row being yes or no, or if row being yes or no, yes or no. Well, actually, so one quick thing. I also just want to make sure, let's just do a quick df.head so we can look at the first few rows and just verify everything. So the first 5 movies are indeed yes. Just so we can see, so for actually, I'm going to create a sample out of this. So df sample, just because just to keep things simple, I don't want to have this engineering run on the full data set yet. So df sample equals df head. All right, so there we go. All right, so df for that and iter rows. So if being yes or no equals yes, print. Okay, so this is what is called an f string, and what an f string is. So you can see. Well, let me just, this is kind of silly, but like, so if we go in there, so you could see that all these are just printing out hello every time, meaning that it did work. But what the f string does is, so this is just printing a string. Like, let's say we actually wanted to put like one of the values from these movies in here, then an f string helps us to like inject like things into a string pretty easily. But I actually think that you do have to like extract the movie name because there was some weird business going on. So I'm going to call this movie name equals row movie name. I hope some of this, again, feel free to ask questions as we come along here, just because I know some of the stuff that I'm saying makes sense in my head, but it might not make sense in yours. And that's totally fine. My brain's weird. So all right, so print f. So this is how you do an f string. So you started with the letter f, and then you put your quotes here. So, all right, so I'm going to put movie name is I'm just going to put got a positive rating, and then I'm just going to do an else. Well, just to make sure it really does work. So like I actually am going to type this out. Because we can get by with else, just because else there is only one other option. But I'm going to do this anyway, just because why not? Being yes or no. Yes or no. Not now. No. Equals no. Then we're going to do another f string. And so obviously it's not overwriting anything here. And actually I am going to do the full sample here because why not? So df.iter rows. So movie name name got a negative rating. All right. Rating. All right, so let's see what happens when we run this. So you can see here that it's kind of hard to read. So we got Zoolander 2 got a positive rating. Let's find one that's got a negative rating. Negative. Okay, here we go. So whatever this movie is, 3 Billboards Outside Ebbing, Missouri got a negative rating. I have no idea what the movie is. Oh, I know what Cloverfield Paradox is. So that got a negative rating. Okay, so we know that this if statement works. Now we just have to properly do the engineering to where we can. Okay, I'm trying to remember how this works. Let's just keep doing with our df sample, because I don't like to overwrite our primary data frame that we're working with until we know it works. All right, so just to show you again, those things got a positive rating. And I think the way it works is I think I have to do df sample dot loc. I think it's you pass in the index, and then I'm going to call it being yes or no. So we're going to give a value. If it is a positive rating, it gets a yes. If it's a negative rating, then it gets a no. So I'm going to copy the same thing here, and I'm going to put this down here, and then obviously the only thing different here is going to be that. All right, so let's see how this worked. Okay. I don't know what this necessarily is. There is a way to suppress warnings, by the way, if you don't like to see these warnings, and I think I might go ahead and turn that on. And in fact, so the way you do that is just at the top here. I'm going to import warnings. So by the way, I know this looks very messy. I do like to clean these things up later, but just to save time for you all, I'm going to not focus on that right now. So I just did this like a couple hours ago, so let me look in here. I know I did it in this notebook here. So I know you have to import warnings and then you have to filter warnings. What is that syntax? Okay, here we go. Hiding any warnings. Hiding any warnings. But I mean, I'm doing this just because I really need to look at this more, like what this warning is. I see this all the time. I honestly don't know what it's doing, but I've never had an issue with it. Like usually when you see a warning like this, a warning's an indication usually like, hey, this thing is going to get sunset at some point, and therefore you need to use this new functionality. But I've not. Whenever I like try to overwrite like this, I always see this, and this is not what I was just referring to. With the whole idea that new functionality is upcoming. So I don't know what this is. I needed to research it some more, but if anybody knows, feel free to reach out to me and let me know what this is doing. But all that to say, this still does work, so hiding any warnings. All right, so rerun that, and so if I rerun this again, all right, so let's just check df sample dot. Okay, so it looks like it properly did our encoding. All right, so I am going to go ahead and change this to just be the df, and I'm going to change this and here, and I'm going to make a comment for myself. So again, I am a very heavy code annotator, or commentator, if you will, and that's mostly for me because, like I said, we're gonna get through as many of these as we can today before I just get tired of doing this and need to go take a nap. And then so when I come back later, I don't want to have to read the code. It's easier to read the comments associated to the code block. So for here, I'm doing performing the encoding of the bean yes or no feature. Bean yes or no feature. Okay, so we should be good to go then. All right, so I just ran that. So let's look at I'm going to do a df.head. And then, so by default, it just shows 5. If you want to show more than that, you could just put however many you want here. Okay, so there we go. So so in case you're wondering why, so this is one of those examples where he gave a really high score but did not approve, and I know why this is. So, and I think I mentioned this before. So, Kalen Bean is actually the son of actor Michael Bean, and I actually haven't seen Terminator. I'm ashamed to admit that. The Terminator stars his dad, and there is a scene in which he makes love to who is now Kalen's stepmom. And that is why he gave it a negative or a no score here, is because he did not like watching his dad make love on scene. So that, again, I mean, he's got his reasoning. His reasoning's not crazy. Like, I don't blame him for that. But I've not seen San Andreas, but it looks like, this one's a little more in line. So he gave it a lower score and then gave it a negative rating overall. So let's do a tail. So head shows the first few rows. Tail shows the last couple rows. Let's see. Did he have any more in here? So he didn't like Jumanji. I think, yeah, this is the newer Jumanji. He didn't like whatever this other movie is here. Now this is curious. I don't remember why he gave The Girl Next Door such a high rating, but a low thing. But anyway, I'm digressing here a little bit. But anyway, just verifying that this did work. The feature engineering did work. In fact, I'm going to do a value counts here. So being yes or no, not yes or on, yes or no, not value counts. Okay, Okay, so you can see that again. We have the 95 yeses versus 26 nos, and then again 95 ones versus 26 zeros. All right, so this is good. This feature, boom, check one off the list. All right, so let's do another df.info just to look at what's next up on the list. Boom. All right, so we did the name, we got the scale, good to go. We just did yes or no. So, all right, so next thing up is just dropping the IDs. And so I'm probably going to reorder all of this feature engineering, by the way, at a later point. I usually like to do the dropping first. It doesn't matter, but, you know, just for cleanliness sake or my own personal organization, I am going to drop these first later on. So the way we do that, again, is df.drop. All right, so then in parentheses, we do columns equals, and then we need to, within brackets, we need to put in those two values. So TMDB ID, and then also we're going to drop the IMDb ID. And while we're here, is there anything else that we need to drop? No, everything else is good to go. So we're going to say in place equals true, and those are gone. All right, or they should be gone. So let's do another I'm just going to rerun the same cell. So this is another reason that, like, we're actually going to spend another stream doing this because we're doing everything in Jupyter Notebooks right now. This is not a great practice whenever you actually want to deploy these models out into production, whether they be for training and then inference. And that is because Jupyter Notebooks have the convenience of running cells out of order. And that can be a challenge, especially if you are a data scientist and you know, okay, I need to run this cell, then 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 this cell to get everything working. That's not great if like, you know, that data scientist gets hit by a bus and then somebody else has to pick up their work. They're not going to inherently know that you had to run those cells in the weird order. So that's why we don't have production scripts in Jupyter Notebooks. We take out our final product and put it in actual Python script, which we will do in another stream. Okay. All right. So what do we got next? All right. So budget's up next. Let's check out budget. I think this is going to be one of those where we should be good to go. So budget. Okay. So by the way, if you'll notice here, if you just do a df.budget, it will just show these values. I actually like to see it as part of the full thing. And the way to do that is you basically wrap it around again within the whole thing. And so if you do that, then or if you want to see it in more of like a data frame format, you just have to wrap it again with another set of brackets like that. So you can see all these are integer values. I'm going to assume these are dollars. I wonder if there's a way to... So I struggled with this last time, and I don't know if it's because of my Mac Mini or what. Budget.hist. Yeah, I keep having this issue. Or I wonder if it's just because I'm not importing something properly. And maybe it's a magic command that I need to add. So again, reminder, I'm not a data scientist. So some of this stuff... you'll see when we get to the machine learning engineer side of things, which is what I do for a living, that like I'll be a lot better because that's the stuff I do on a day-to-day basis. So I have a lot more of that stuff memorized. But again, memorization, not really super important. Obviously, it speeds things up if you do know things, but you know, it's not a deal breaker. I think it's more important to be conceptually savvy. Now, okay, let me rephrase that just a little bit as well. If you are like a genius with understanding like the mathematical stuff underneath an algorithm, but you don't know a lick of Python, that's also pretty bad. So you actually do need to know some Python or pandas. Like you need to have like a general idea of knowing where you need to go. So even though I'm saying you do need to have the conceptual understanding, you do need to have like a general direction of like understanding the syntax of things as well, because it's not really helpful to just have like nothing but a very, 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 very conceptual idea of things. All right, so I got a little distracted there with my little diatribe, so I got to go back in here and remember what we're doing. Oh, the histogram. All right, so pandas hist show in Jupyter. So I'm going to just Google that. All right, plotting with matplotlib. All right, so let's see what this person has to say. All right, so they're installing this. So matplotlib.pyplot. So I just wanted to see necessarily how do you do it with pandas, not necessarily matplotlib. Although I will say matplotlib is obviously the better choice for visualizations, but you know we do have this at least. So let's do .hist. So pandas hist maybe the official Pandas documentation would be a little bit better. By the way, I'm gonna turn on my fan real quick because it's kind of hot here. I would take off my hoodie too, but it's fine. Just turn on the ceiling fan. Okay. All right. So column.hist. Do I have to import anything special? Okay. So this function calls matplotlib.hist. So I wonder if I just need to import matplotlib.hist from matplotlib.pyplot. Oh wait, no, I shouldn't have to do that. I wonder if I don't know. I guess well, I really do want to kind of figure this out because I do want to show this. All right, so I'm gonna just do matplotlib.hist not showing. There we go. All right, what do we got to do? Matplotlib.hist. Maybe this person knows what they need to do. So you need to call plot.show. Okay, let's try this out. So matplotlib.plot as plt. All right, so I'm gonna come back into here. We can close out this tab. Import mat, and I don't even know if I've actually installed matplotlib on my Mac Mini here yet. Matplotlib.pyplot as plt. Okay, apparently that worked. All right, so let's go down here. So plt.show, plt.show. Is this gonna work for? Oh, there we go, hot dog. All right, that did fix this. All right, except I don't know how to necessarily read this. Okay, so what this is showing here is 1e to the 8. So this is basically saying we kind of like because these numbers are so big that we kind of crunch them down into like a, oh my gosh, what is the mathematical term? It's basically saying that like, we're scaling this down. So I'm going to assume that this here represents like $1 million. Some of these are really, really big, but you can see that it's kind of skewed toward the right. So like more movies had a lower budget than some other movies. So I'm very curious, is there a way to do a sort? So df dot, all right, so let me sort, do a panda sort. Pandas sort by values in column, because I just want to see which one of these movies had like the highest budget. All right, so sort values. All right, so just show me your example. All right, so sort df.sort values by equals time. Okay, so it's by. All right, so let's do df.sort values by equals budget. All right, tell me what's going on here. All right, that did work actually. Oh, look at that. Avengers Endgame. Of course it made that much, or cost that, or had that big of a budget, but they probably also had a really, really high revenue, which you can see here. All right, so this actually did kind of work. So, oh, dang, this is interesting. Okay, I'm glad we did this because if you're noticing here, there are actually several movies that don't have a budget, or a budget recorded as 0. That's concerning because we need to figure out what we need to do with that. Because obviously these movies didn't cost 0. And I wonder how many of these have a 0 like this. So I'm glad we did this because this is, in my mind, this is a null, but it's not registering as a null. So there are a couple things that we can do here. We can try doing some feature engineering to actually change this. I actually think I want to hold off on this one because, so I think I got this particular feature from TMDB. And if you recall, we had like 3 different sources. And I want to say that the IMDb actually had a budget column. And so now I'm super curious to know if the IMDb budget actually had some of these nulls that we're looking at right here. I'm looking at this a little more closely. Actually, so some of this is not correct anyway. Like El Camino here is showing as animation and family. El Camino is that movie that was like the Breaking Bad follow-up movie on Netflix, which is obviously not animation and definitely not family. But I think that was one of those things that I mentioned that we were going to just have to accept, like that there weren't going to be some great values. But anyway, let's do a value cancel on this. Why not? Df budget dot value counts. So yeah, so this is again this idea where we went through and so you can see we got 26 movies that don't have anything. That's 1/5 of the movies. So this is one of those things where we might actually just end up dropping this feature. So actually, I'm gonna hold off on doing anything. I do want to check IMDb to see if it has better data than TMDb did, because there's too many nulls here for my comfort level. So let's just keep moving on. I'm gonna make a note of this, and we shall return. All right, so let's go to primary genre. Primary genre, I do know have some nulls, and that's okay. In secondary genre. So the thing that we need to do for here is do some what do we call it, the one hot encoding. So I do want to import one hot encoding here. So I'm trying to remember what we call that because I'm going to use category encoders if you recall from our Titanic project. Category encoders one hot. All right, so category encoders one hot. All right, so there we go. All right, so it's from category encoders dot one hot import one hot encoder. Okay, so from category encoders dot one hot import one hot encoder, like so. Okay, so we have imported that. All right, let's scroll back on down. So again, we're working on the genres column right now, or at least the primary genre. We're going to be basically doing the same thing for the secondary genre. Okay, so I'm trying to remember what the syntax for doing things here is. So okay, so we pass in. Well, actually, I'm actually going to just reference what we did for the Titanic project because I remember having some struggles, and it's easier to reference previous work sometimes than it is to reference documentation. So Titanic, where are you at, Titanic? There we go, Titanic, and then we had notebooks, and then we did our feature engineering, and now I'm getting cold after turning on my fan, sorry. So, okay, so we imported the one hot encoders. All right, so we did use the cat names. Okay, so I basically just want to copy this here. So I'm going to call this, all right, go back into our actual feature engineering. So I'm going to call this one hot encoder. So I'm going to call this primary genre encoder equals one hot encoder. And then basically we're going to do the same thing for this other one here. And so right now, by the way, we are just doing things, just one-offs as like curating the data set by ourselves. But whenever we actually want to go and like package all this up for like a production pipeline or whatever, we're going to put this as like part of a scikit-learn pipeline, which you might recall is what we did with the Titanic project. So primary genre encoder, and then we're going to call this secondary genre encoder. I'm going to put defining the encoders, or the one hot encoders, the one hot encoders for genres. The genre columns. Okay, so we are defining those. All right, and then we have to go and fit them appropriately. So let me just look on how you do it. I think you just do a fit transform. So I'm going to call these the all right, so primary genre dummies equals one primary genre encoder and encoder dot. Is my face in the way, by the way? I think it might be. Let me move my face up. Boop. All right, so primary genre encoder dot fit transform, and then we want to pass in the df primary genre. Okay, so let's take a look. Dummies. Let's take a look. Okay, so what we got is a bunch of different new features associated to all the different genres, and then we also have our NaN column here at the end, which just looking at this, I mean, well, let me do a df head just to verify real quick. All right, so we got a crime. All right, remember this with me, folks. Comedy, crime, comedy, action. All right, so we got comedy. There we go. Crime. There we go. Comedy again. There we go. Action. There we go. So is the fifth one drama? Let's go look. Drama. Okay, so this worked. Simple enough. All right, so I'm going to do the same thing here. I'm going to say getting the one hot encoded dummies for each of the genre columns. So basically, we're going to do the same thing here for the secondary one. Of course, it's going to be what instead of copying and pasting, I'm just going to type it all out. Secondary genre encoder. Actually, you know what? I think it would make more sense to do like the drop at the very end, just because we're going to have to drop the original column once we do the coding here, because we won't need that anymore. I'll make a note to do that later. Again, we're just going along. Organization is an important thing, I think, but for just to save time for our streaming here, we're not going to worry about that so much right now. All right, secondary genre encoder dot fit transform df secondary genre. Okay, so did I not spell that right? Well, I didn't spell the original one right. Secondary genre. Secondary. Oh my gosh, come on. There we go. All right, so then we have. All right, let's just take a look at these really quick. So secondary genre dummies. Okay. And it looks again like it worked all right. So let's just, before we look at our raw data set again, let's just see. So the first one should be null, and then the next two should be drama, and the next two after that should be adventure. And lo and behold, so the first one's null, second two are drama, and the next two are adventure. So this worked. All right, so what we got to do next, so because these are basically their own data frames right now, separate from our overall data frame. So what we got to do is concatenate them to our original data frame. So and I think we could do that in one fell swoop, I think. So df, or I'm going to say df equals pd, or before we actually do it, let's just do the pd concat. And so what we do is we have to pass in each of our respective data frames. So we're going to pass in the original one. We're going to pass in the primary genre dummies. And so I've never tried this. I've only done it with 2. I don't see why we can't do it with 3. And just, concatenate them all in one fell swoop. Dummies. All right, and then so I think we have to put axis equals 1. And okay, so these are the original columns. So if we keep scrolling on over, we should see our new ones. And so, by the way, you'll see just for cleanliness sake that by default pandas only shows, like you can see the 3 dots here. They only show so many columns. You can change that. I don't remember how you do that, but you can have it to where it always shows everything. I'm not going to worry about that because I'm trusting that this looks fine. So we did that concatenation, but obviously we just did it ephemerally, meaning that it didn't get saved to anything. So we're actually, quick way to do that is we just do df equals pd.concat. All right, so concatenating the genres dummies to the original data frame. Okay, so there we go. Boom. All right, and then we can drop the original column. So dropping the original genre columns. So the way we do that again, df.drop columns equals, so what we got, primary genre, and then secondary genre. No need for these guys anymore since we have already feature encoded them. In place equals true. In place equals true. Actually, let me just show you, like, I'm sure you could Google this yourself, but we'll go ahead and do this. So pandas view all columns in Jupyter. All right, so show all the columns in Jupyter. So it should just be as simple as like displaying. Yeah, okay, there we go. It's this thing here. It's just this little piece of code. So let's add this to the top of our notebook. So I'm going to put it in the same cell here. All right, showing, or I'm going to just put adjusting pandas output. And the reason I'm saying adjusting pandas output, because we might want to add some other options as well. I wonder why it said 20. That's weird. You see that? I don't know what that means. All right, but we should be able to go down here again and just let's look at our just do a df.head. All right, so that didn't work. Did I not do something correctly? Because we should be seeing all of our columns now. Display dot max columns, pd.get option. So let's check this again. Output equals 20. Depending on your pandas version result, you may get a different number. In our case, the result turned out to be 20. That is, if a column has more than 20 columns, it will skip a few columns when displaying that. Okay, so all right, so that makes sense. All right, to display all columns, in a data frame, you can change the pandas settings. Let's go ahead and change the max settings display to parameter to none so that all are displayed. Okay, so that was correct. Okay, and that makes sense, I guess. So let's do a none, and so I wonder why it said output again of 20. So, but let's see if this worked anyway. No, it did not work. Now I'm just a little bit baffled on why this is not working. Display.max columns. Did I not type something correctly? It could have been that I just didn't type something correctly. It's happened. Been known to happen. All right, pd.get option. Well, why does it say get option? It should be set option, right? Yeah. Okay, so that time it didn't have any output because that's what I'm used to seeing. And now it should work. Okay, there we go. Now we can see all of our columns. And again, you may not want to do this just because it kind of it can be a little like tedious scrolling through these things, but we can verify 100% now that these columns were concatenated and that we do not see the other stuff. All right, so we are good to go here. So let's just do df.info just to see what our data frame looks like right now. And as you can see, and this is exactly what we want to see, is that we have integer values for all these different columns and none of them are null, which is exactly perfectly what we want to see. All right, so we did that. So as we recall, we did the budget. Let's see if we can get through one or two more features today. So a little transparently, like I'm just not feeling great right now. Like I know you can't hear it, but in the back of the back of my throat's feeling really scratchy right now, which is usually like the indicator that I'm getting a cold. But the way I kind of tamp that down is I usually go take like one of those emergency like tablet things, and that usually, like if I can take an emergency right now, that usually like squashes it before it becomes anything. But for now, I'm just not feeling super great. But let's do one more feature. Why not? Because we're gonna have to come back and revisit some of this anyway. All right, so TMDB popularity, or maybe this one's already good to go. We'll do at least feature engineering on one more that needs it. So TMDB popularity, and then as you recall, if you want to see it in like the table like format for pandas, then you would just put another bracket here. All right, oops, missed my bracket. All right, so there we go. I don't know what this popularity means. I really should probably Google what this means. Actually, let's go ahead and do it right now. TMDB popularity. All right. Popularity rating. Looks like somebody else asked this question. I apologize if somebody's advanced. I would like to know what the popularity score is. You can read about how this is calculated here. Thank you, Mr. Travis Bell. All right, so popularity is a very important metric here on TMDB. It helps us to boost search results. Each model builds their own popularity value differently. If you're curious as to how and why, check out the information below. So movies, number of votes for the day, number of views for the day. So it looks like this might be a variable value, meaning that like it might change from day to day. So for example, it's actually, we've been using the Matrix as an example, which is actually a great thing. So the Matrix came out in 1999. And then the following sequels came out like 2 or 3 years later. And, you know, not that it's not fallen off in popularity, but it's recently caught on in popularity again because of the new Matrix movie coming out. So I'm wondering if that's what this represents. And if that's the case, that's a highly variable value that can change, you know, because, you know, the Matrix is, again, popular right now because of the new Matrix movie coming out. But, you know, in about a year, it probably might not be as popular again. So we actually might not include this feature at all. So I'm glad we kind of Googled this. So I actually am going to make a note here that we should, well, we're actually going to drop this column. So dropping the TMDB popularity column as it appears to be highly variable per the day it was polled, meaning that it changes very frequently over time and probably is not a good feature to use for our predictive model here. So we're going to do a df.drop columns equals tmdb db popularity in place equals true. All right, so let's just do a df.info again. Okay, so you can see, boom, it's gone. All right, so vote count, vote average. I should probably look up what those are as well. So I know this will be a little bit variable. You know, obviously as new movies come out, that they're not going to have as many votes as the old one. But I still want to keep that because I kind of feel like even that will change, that like, you know, a movie like Avengers Endgame, for example, is going to have a higher vote count, which kind of is an indication of popularity in and of itself. Popularity in the sense that more people are watching that movie, and so that can be a predictive value, and therefore I want to keep that. And so let's go ahead and look at what the values of these are. So vote count and vote average. So df actually, so we can look at both of them at the same time. The way that we do that is df what is it called? Apologies. TMDB vote count and vote average. TMDB vote count, and then we do a TMDB vote average. TMDB votate what? Average, and then we should just be able to key error. TMDB vote average. Did I not type that properly? TMDB vote average. Maybe I have the syntax wrong. Well, let me just delete the one because this should work. TMDB df. Okay, so I think I might have just had the syntax wrong. So let's put this back here. So TMDB vote count, and then we should be able to look at both at the same time. Okay. Yep, I just had a little bit of syntax stick up there. Okay, so as you can see, it looks like they're at, like, this might be a 10 scale. So actually, let's go ahead and do a histogram on this one. So df TMDB vote average dot his. So this will actually be really interesting. Before we run this cell, let's all take a guess. I'm gonna take a guess that it's going to be like center skewed. I don't know if that's the correct terminology, but center, like more like a natural bell curve, but more centered to where everything's more like a 6. Let's check. Oh yeah, that's right. We have to have that extra little piece of code in here, don't we? The little show here, plt.show. Okay, let's look at that. Okay, so I was kind of right. So you can see here that we have like a normal distribution, more or less, with a little bit of a left tail skew here, which, by the way, I wish I understood how skew like what the skew language means, because I thought skew always meant like so you can see that there's more stuff on the right side here, that it would be skewed right, but it's actually, the way I remember is if it's got a longer tail that way, then it's actually skewed left, or versus a longer tail that way, then it's skewed right. I don't remember. I'm struggling to remember why that is, but anyway. So this is pretty much more or less what I was expecting, and therefore I don't need to do anything with that. And likewise, well, let's do a show on not the vote count, but the vote count. Sorry, vote count. But my hunch is that we don't have to do anything with these. Oh, ooh. Well, actually, no. This is not really surprising. But the question is do I want to keep this feature anyway? Because it is a very heavily rate skewed. Let's do that sort by thing again, because I want to see what the highest votes were. Let's take our guess. I'm gonna guess it's Avengers Endgame again. So TMDB vote. Oh wait, no, it's sort. df.sort values by equals. What is it? TMDB vote count. Okay. Okay, so there's Midsummer's got the lowest. Oh, Deadpool's got the highest. Okay, but you know, Avengers, both Infinity War and Endgame got pretty high up there. So I guess that's not entirely surprising. I kind of forgot that Kaylin rated Deadpool. So okay, so that's pretty accurate. I don't think I am gonna do anything with this feature. I think it's good enough as is. I know it's a little bit on the skewed side, but I think that should be okay because it's not. It's not like crazy skewed. I'm curious. I don't know what Midsummer is, but it looks like some of these got some really low votes. But let's keep it. So, by the way, in another future stream, I do want to do work with something called Shap and Lime. Shap and Lime are algorithms based in game theory that help to show feature importance of a model after it's been trained. So it's kind of opening up the black box of a trained model to understand, like, okay, saying these features are more important or whatnot. And so, and the reason I want to do that is because I want to see after the fact, like, which of these features were actually the most predictive. I'm going to make a guess right now that Rotten Tomatoes audience score is going to be the most predictive. That's just a hunch, but I could be wrong. But anyway, so we're not going to touch those. Let's go back and look at our list here again then. So vote count. So again, we have the IMDb kind of stuff here. So let's do the same thing here. Well, I know this is not a best practice to keep running this .info like that. I'm surprised that ran, even though I put another parentheses in there. Although, why does it look a little more spaced out? Am I wild about that? Am I off with that? Or am I just... Yeah, I'm probably going... Yeah, I'm not there. No, this is fine. I don't know. No. So it didn't work with one set of parentheses. I'm surprised it worked with that other set of parentheses in there. Okay, so... Okay, IMDb rating and vote count. So DF... IMDb rating, IMDb votes. Sorry, not vote counts, votes. Just want to make sure like that this is all fine as well. So we are very much doing our ADA in tandem with our feature engineering, obviously, because like what we're doing right now is pretty much EDA, exploratory data analysis. Okay, so you can see here that it looks like we got an IMDb rating. I'm very curious again to see if there's like a 0 to 10 score. So let's do the DF IMDb DB rating dot plot. Is it plot or is it dot hist? Dot hist. That's right. Dot hist. And then plt dot show. Dot show me the plot. Okay, this is interesting. So by the way, I am not a great data visualizer. So if you want to do like fancier data visualizations, you can with libraries like Matplotlib and Seaborn. And the reason I bring that up is because you could actually, I know there is a way to like put both the IMDb rating and this other TMDB vote average on the same visualization, basically. Because it would be very interesting to compare the two, because as you can see, the TMDB vote average appears to basically have more or less the same shape as this. And actually, let me see if I can, because I don't remember how to do it off the top of my head, just like on one visualization. So let's just put them kind of more or less side by side. So you can see like the visualizations. Let me zoom out a little. The histograms alone kind of are very, very, very similar. So that's interesting, but we don't need to do anything with that. I'm going to overwrite this because I've already got it elsewhere. I will clean this all up later, of course. All right, so let's check out the same plot. Well, I guess I didn't need to do that. I just need to replace the variable name here. IMDb votes.hist. All right, anything concerning here? So I think this is the same sort of idea. Where with this one up here, in fact, let's do this again by vote count, but let's just do IMDb votes, and what we should see here is, okay, so it looks like on this other platform, so we see Midsummer again here toward the top. So I know this is not right because I know that El Camino probably got, the actual El Camino got higher than whatever this is. Oh, but this is interesting. So we do see that a lot of votes for IMDb were given to, of course, the two Avengers movies. And then we see Deadpool again, but Schindler's List interestingly tops the list on IMDb. But you know, they're more or less the same. I'm gonna keep both features anyway because I think it's good to go. So those features are good. So let's see, what else do we have? We might actually end up cleaning through most of these features anyway, even though I said we wouldn't. Okay, so all right, so we've got votes. We also got I know year should be pretty simple actually, because it's already an integer format. I just need to change it to a relative value instead of this actual value. So I'm gonna call this. All right, so we're gonna do the we're gonna use our df sample again. All right, so for this actually should be really easy now that I think about it. So for df for row index row and df sample dot iter rows. Well, actually, I want to do this in a more automated way, and instead of having the static value being 2021, we can have use a Python library to get the actual year in which the code is run. So let's say I run this in a couple months, 2022, then I don't have to go back and change that static 2021 value. I don't remember how to do that off the top of my head, but you know, that's what our friend Google is here for. So let's do Python get current year. And I'm sure it's the datetime library, I just don't remember. Let's go into this one. So from datetime. All right, so looks like how you do it. So from datetime, import datetime, and then it looks like we should be able to do this. So coming back to this notebook, and let me close this one out just to keep things simpler. All right, scroll back up. I like to put all these things at the top. So from datetime, import datetime. Oops, from datetime, import date time. All right, so scroll. Let me just do this here. So let's see, did this work? Current year. Yep, that worked. All right, so now we can go through and do our iterations for through the sampling. So what we basically, here, let me zoom that in again. Sorry about that, folks. All right, let me take a sip of my drink here. All right, we're gonna engineer a new column called movie. What should we call it? Let's call it movie age. Why not? Movie age equals current year minus the actual row. So it's current year year minus the rows year, and then let's just print it out. Print. We'll do an f string again. So f. So move. Well, so oh yeah, we gotta extract the movie name again. Movie name equals row. Movie name, right? Movie name. All right, because I don't know why the f string doesn't like to just inject this immediately. I'll have to Google that at some point. So movie name. Whoops, I meant to put that in here. Is movie age years old. Well, actually, let's was created in. We'll call this movie year released equals row year, and then I guess we can change this to year released. All right, was released in. Oops, I accidentally hit the. Sorry about that, folks. I hope you all can still see me. I think I mentioned before that I use like Apple's like Magic, not the Magic Keyboard, but one of their keyboards, and you can see right above that delete key is the lock key, and gosh darn it, I hate that placement because I hit that thing all the time. Clearly. All right, so let's do this again. So I got a little distracted with that. All right, so year minus year released. So was released in year released and is that many years old. Okay, so there we go. is this not right? This is not right because why? Because it's got the movie name right, but it's saying all these were released in 1997. That's not right. Although the relative value is just fine. Let's check out DF sample. What's going on here? DF sample dot head. DF sample dot head. Where is the year? Year. Okay, why are those all listed as 1997? Is that just my problem here? Did I accidentally overwrite something when I did something? I may have. Okay, so something's wrong with the actual code here. I wonder if they're all like that, because I am 100% sure these movies were not released in 1997. So it looks like something was wrong with the actual data engineering, so I have to go back and look at that. So this, I guess this is a kind of a good thing, a blessing in disguise, if you will, that, this is the reason it's important to look at all your features, is because, you might assume automatically that a feature is good to go, and then when you actually look at it, then you realize that it might not be. So let's check df year.value counts. I got a hunch that every single one of these is going to be 1997. Yeah, something is wrong with the feature engineering. I must have screwed something up. No worries, I can go back and fix that. But we're not going to be able to properly engineer this feature until it works. But although I will say that it looks like this code works. So basically what we're going to have to do is go through, in fact, I'm going to go ahead and create a new column, but even though it's all going to be the same 24 years old. So movie age equals that, and then we want to do a df sample dot loc, and then we're going to put it in the index, and we're going to call it movie age, and then equals movie age. Okay, and so then when we go into df sample again, and then I guess we don't really need the head because there is only 5 rows in here. Okay, so when we come on over to here, so then you can see off on the far right here, then that is a correct value. So the logic to actually do the feature engineering is correct, but the data itself is not correct. So let me go ahead and put a comment here. Engineering the year column to be a relative years or movie age column based on number of years since original release. So, excuse me, I gotta go back and look at the actual data engineering column features, but something is wrong there. But I'm kind of glad we saw that. So let's keep going. But at least the logic here is still sound. Like this should be good to go after we fix that. No need to change anything here. All right, so let's do a df.info again. So I think there's just is one more feature, 2 more features actually: Rotten Tomatoes critic score and Rotten Tomatoes Metascore. So let's check out the critic score. Well, let's do both at the same time. Df RT critic score, T critic score, and then let's check out the Metascore as well. Score. Oops. All right, so we do need to do just one quick, I forgot about this, we do need to do one quick little thing here so you can see that this is currently in string format because it's got the percentage sign. So let's go ahead and engineer that out real quick. How do we remove the percentage sign? What's the best way to do that? I'm going to take the easy way out. So I'm going to say for index row in df iter rows, again as per usual, we need to do the RT critic score. So RT critic well, let's just do a print. So I'm going to turn this into an integer value, and we are going to take just the row critic RT's critic score, RT critic score. And then what we do here is we're going to take the first 2 digits just because we know we want to get rid of the percentage sign. There's probably a better way to do this, but this is one way, more than one way to do things. So you can see here then we have, so we have a float in here. What's going on? What's going on? Float type is not subscriptable. I actually noticed this earlier. I wonder what movie this is for. Let's just go ahead and print row dot movie name movie name, just so to see. I like to do this to see where it got hung up. It got yeah, okay, so it got hung up on Suicide Squad the last time too. So let's do a search. So df row, or I'm sorry, df movie name equals Suicide Squad. And so this is the older Suicide Squad. It's the older Suicide Squad, not the one that just came out like 2 months ago. Okay, so let's look at where is the Rotten Tomatoes score. The Rotten Tomatoes credit score. Oh, it's listed as a null. Oh, that's why it wasn't working before. Because we got to handle the nulls first. How do we want to handle the nulls, folks? Maybe it's more if. Okay, so if row is not nan, then we do this little engineer. So if row dot rt critic score is not np.nan, print everything else out. So let's see if this works. I don't know if this is going to work or not. Or let's just do is none. How about that? Okay, that did not work either. Is not none. All right, so what is this? Let's just get the nulls out. I'm struggling to know how to do like the proper way to do this. We got to get rid of the percentage sign first, because I'm still struggling to know like how to handle those nulls in general. Do we want to do imputation or not? Or maybe I should just do something where, because right now we're just trying to get the first two characters. But well, that's because of the null values though. What do we do? Because we just want to skip through anything that's null for now. Is if not none, but it is none. Flow type is not subscriptable. Well, why is it saying that it's not subscriptable? Because that is not a. It is a null value, right? So what do we got to do? Is not none. Flow type is not subscriptable. Well, okay. Let's just out of curiosity. So we have this df movie name Suicide Squad, rt critic score. So it's showing it as a dot type, d type. D type. I didn't think that was gonna work. Dot d type is object. So it's still registering as a string, I guess. Well, I guess let's look at this. Let's just do an info on general. In general. All right, so for loop. Okay, so it is registering them as nulls. I don't know why it's it. All right, so let's do pandas editor rows skip over nulls. All right, let's see. All right, so iterate through data frame and select nulls. All right, so what does it have to say? If pd.is null. Oh, okay. pd.is null. If row, if pd.is null, if row dot is null, or is it not null? If it is not null, pd.not null. I don't know. I'm losing a little steam. I don't know if you can all tell. Okay, that actually worked. Okay, I'm very surprised. I'm very surprised it did work, but I'm happy it did. All right, so I'm gonna call this removing percentage sign from the critic from RT critic score. I don't know if you can all tell, but I'm like struggling right now, but I want to get through this because this is basically the last feature right now. All right, so if not null, so all right, equals int. Okay. Okay, so what we want to do here then is before I delete that, so df dot loc index, and we're going to call this the RT critic score equals basically this. equals this. This. All right. Let's hope this works. Okay. All right, it ran just fine. So let's check. df dot df rt critic score. I forgot we have the metascore to do as well. All right, so that appears to have worked. So df.info. All right, so is it showing all these as, well, it's still showing as object. I wonder if there's a way to I guess I shouldn't have done it like this. I should have done it in a way where instead of casting it to the integer at this level, we should have done it at the entire level, which we shall fix. Not now. I'm losing too much. I'm losing too much steam, and I think we've come far enough today. I think you all get the idea of what we're doing here. So we just have a couple little feature engineering left. I'm going to clean all this up. I'm going to figure out what the issue was with that. What was that one feature that the year was not working correct. And then I'm going to finish it all up. I'm going to save all this out later to like its own massive data frame, and then I'll push it all up to GitHub if you want to watch. So I guess we won't do another feature engineering stream because we got through pretty much everything. I guess in our next because the next stream is naturally going to be. Well, let me go ahead and we're done with this for now. The next stream is going to be starting to do the model algorithm. So you might recall for the Titanic stream, we just did random forest classifier, settled on that, and called it a day because I want to make sure this thing is as accurate as possible. We are going to be testing out a number of different algorithms, which means we're going to have to do things like scaling and whatnot on our data. And also, I want to do something called. It's been a long time since I've done this, but one concern about training data is if you have a relatively small data set, which we do, is that if you do like a train test split on it, then you are obviously losing out on whatever percentage of the data set you called validation. And so what people have done to kind of alleviate this is what we call a k-folds validation. And what it's basically doing is then, I don't know if I'm going to explain this well at all. It's basically a way to use all of our data. I'll explain it better another time because I'm losing the steam and I got to re-Google what that means. Again, I'm not a perfect data scientist. I'm more of a machine learning engineer, but this is a great practice for me as well to kind of brush up on these skills that I don't get to work with on a day-to-day basis. So apologies again if it seemed like a little low energy. I hope you enjoyed the stream anyway. I still had fun. And I'm going to go take a nap. So I hope you all have a great weekend, and I will see you in the next stream. Catch you all later. Bye-bye.